Hi everyone, this is Professor H. Rahman from Agricultural and Food Engineering Department, IIT Kharagpur. I welcome you all to this NPTEL course on traction engineering. This is a tutorial class where I will try to cover how the length of track is influencing the performance of a walking tractor, and then we will try to discuss about selection of a suitable tire size for a given size of tractor. So, first these are the parameters which will be utilized for deciding the influence of track length on its performance, and some of these parameters are also responsible for selecting the tire. So, that is I have listed all these parameters which will be utilized in those two problems which I am going to solve. The problem is very short in the sense a statement I have given: a shorter track will sleep more than a longer one if they are to develop the same tractive effort. This is the statement, we have to justify this statement. So, in other words, what we are doing is we are trying to say that if a track is having longer length, it will always develop better tractive performance. That means, it will develop more tractive effort. So, to prove that, you have to take one example: a tracked vehicle with uniform contact pressure, which is whose weight is given, and it has the option to be fitted with say tracks of different lengths, starting from 1.5 meter, then we have changed to 2 meter, and the contact area of each track, because the vehicle will have two tracks. So, each track contact area is given. If the vehicle is to be operated over a terrain that has been characterized by a exponent of sinkage n, whose value is 0.5, and cohesive modulus of sinkage 0.77 kilonewton per meter raised to the power n plus 1, then frictional modulus of sinkage 51.91 kilonewton per meter raised to the power n plus 2, then cohesion 5.17 kilopascal, angle of internal friction phi as 11 degree, and shear deformation modulus k is 5 centimeter. So, under these conditions we have to select a suitable pair of tracks. That means, the track which is giving better tractive performance, that will be selected. So, since the question is the longer one should give higher tractive effort, so the equation which is related to tractive force for a loose sand, and the weight, assuming the weight of the track is uniformly distributed over the ground. So, the equation is F is equal to AC plus W tan phi. So, this is maximum thrust So, this is your maximum thrust developed, this bracketed person, and this is the person which is portion is due to the variation of slip and length. So, this into 1 minus k by I L into 1 minus e to the power minus I L upon k. I is the slip, L is the length of the track. Rest of the things are same for both the soils. If you look at the first bracketed term, W is also same. Whether it is a smaller track or there is a bigger track, W is kept same, and contact area is also same. Okay. So, this is the governing equation based on which we have to find out what will be the which one will be giving the better tractive performance. So, what I have done is I have taken 2 meter length as a track for one track, then I try to find out at 20% slip what is the tractive force which is developed utilizing this equation, because all the values are given. A I have taken as 1.5 meter square and length of track I have taken as 2 meter, okay, and slip I have taken as 20%. So, what we observed here is we are getting a tractive force of 124.23 kilonewton. Now, I change the length to 1.5 meter, and what we observed is a tractive effort which is lesser than what is observed in case of 2 meter length. So, what I did is I varied the percentage, slip percentage from 20 to 30%. Then what I observed is the tractive efforts is matching with the tractive effort which is developed in case of 2 meter track, but slip is different. So, again we tried with another slip value. For a 2 meter track length, I changed the slip to 30%. So, I got a value of tractive force as 132.45. Now, to get that tractive force, again I tried with a 1.5 meter length. That means I changed L to 1.5 meter, and what I observed is when the slip is 0.45, that means 45%, then only we are developing a tractive effort which is equal to the tractive effort developed by a 2 meter length track. So, from these two observations, what we can conclude is it is the length of the track which is giving you more tractive effort for the same slip. Now, the statement which I said, a shorter track has to slip more than a longer one. So, if you look at this, to get the same tractive effort, the 2 meter track length slips only 20%, whereas the 1.5 meter track length it slips 30%. So, the statement is proved. To further check this one, if you look at 2 meter length at 30% slip, we are getting 132.45 kilonewton tractive effort. To get the same tractive effort of 132.45 kilonewton, the shorter track, that means 1.5 meter length track, has to slip by 45% to develop the same tractive effort. So, the statement which is given like a shorter track will slip more is now justified from this example. So, basically it is the governing equation has to be remembered, and then we need to know how to utilize this equation by the parameters like soil parameters and weight coming on the track and the contact area of the track and at different slip values, then only you can calculate. So, the next thing is a problem which will be dealing with selection of tire. For example, someone wants to have a tractor for a particular size, say 55 HP. If the company people which fit the tires and that is there, you cannot change it because they will say this is the best one. But if you really want to analyze which one is best one, then we have to do this exercise. So, we have to select a tractor tire for 55 HP tractor. So, what are the information we require? We require to know what is the total weight, what is the wheelbase, what is the static weight distribution. This is important. How much weight is coming on the rear axle and how much weight is coming on the front axle, that is important. So, just for convenience, I have indicated that yes, in the rear axle it is 65% and obviously in the front axle will be the rest 35%. Then the other important component is what is the location of CG, how far it is from the rear axle, CG from the rear axle, distance of CG from the rear axle. Then question arises, what kind of implement you are going to select. So, we want that the tractor should give you maximum power. So, maximum power means it is the tillage operations which will give you maximum power. Tillage operations, again the primary tillage operations related to deeper tillage. For in our case, moldboard plow is the implement which is going to give you the maximum draft, and it is the clay soil which will give you the maximum draft force. So, we want to know the details about the implement, whether it is a 2-bottom moldboard plow or whether it is a 3-bottom moldboard plow. Once you select the plough, then what should be the number of bottoms? Then what is the total weight of the implement, that means motorboat plough? Then what depth you want to operate? What is the width? Then at what speed you are going to operate? These are some of the information which you require. Then the most important thing is the center of resistance. How far it is away from the center of the rear axle, and how much below the ground level. If these informations are available and the angle of pull is available, then we will try to find out what is the weight transfer or what is the dynamic weight coming on the rear axle and what is the dynamic weight coming on the front axle. So, before that, once you decided the implement and knowing different informations, the next step is how to calculate the draft. SAB equation is the only equation which will give you draft computation. So, the SAB draft equation is given as this: Fi is draft is equal to Fi into A plus BB plus CV square into MW into TD, where MW is the width, TD is the depth, and V is the forward speed. A, B, C are parameters which values are listed here. For MB plough, we have already decided from that SAB standard what are the values of A, B, and C. Value of A is 652, value of B is 0, and value of C is 5.1. And F1, F2, F3, these are soil texture adjustment parameters. Fi1 means F1 means I could be 1, it could be 2, it could be 3. If it is 1, then the value is Fi value is 1. If it is F2, then the Fi value is 0.7. If it is F3, the Fi value is 0.45. So, basically it is the hardness of soil, in that way if I have to take. For clay soil, we have decided these are the parameters: 1, F1 value is 1, A value is 652, B value is 0, and C value is 5.1. Then we try to find out what is the value at a forward speed of 4.5 kilometer per hour and at a depth of 15 centimeter. This is the draft value which is found out. Then knowing what will be the pull. So, pull will be, if I draw a tractor here, so this is the ground. So, pull will be somewhere here. This is the line of pull, and what I am saying is the line of pull is making certain angle with the horizontal, and the center of resistance is, say, a distance away from the rear axle, and the center of gravity is also at a distance from the rear axle. This is your center of gravity, W. Okay, and you need to know the total weight. So, in our case we have taken as 2400 kg. So, this distance is to be known and it is given 70 centimeter, and this distance, center of resistance is 100 centimeter from the rear axle, and this is the ground, this is 15 centimeter, center is 15 centimeter below the ground level. So, there will be reaction at the front wheel, there will be reaction at the rear wheel. So, this pull I can resolve into two components, Px, which is nothing but your draft, which I have already calculated using the SAB equation, and the vertical component is your Py. So, that Py will be equal to Pe draft by sin cos alpha. So, that will give you pull. Then so, pull will be equal to, so this will be equal to draft by cos alpha, and from P we calculate Py, which is nothing but P sin alpha. So, that way we got 182.12 kg. So, we got the value of draft, we got the value of pull, we got the value of vertical component Py. The next thing is you have to find out what is the dynamic weight coming on the front axle, because we need to steer the vehicle comfortably during operation. So, for steering the vehicle comfortably, we need to have at least 20% of the total weight on the front axle. Okay. So, we have to now find out what is the dynamic weight coming on the front axle and then verify whether this condition is satisfied or not. So, for calculating the dynamic weight, we have to take a moment about the center of the rear axle along the central axis of the rear axle. So, now these are the two forces, then this is the total weight acting, this is the frontal reaction. Since you are taking moment about this line, so what you are getting is Px into this, from the ground it is at a high depth of 15 centimeter plus radius of the wheel plus 15 centimeter. If you want to make it in meter, 0.15 meter. Then because of y, it will be minus. So, Py into this distance plus this distance, that means 100 plus 70, 1.7. Now, W, this is positive clockwise. So, W into 0.7 and then minus this R1, this is R2. So, minus R1 into 2.1. So, if Px value is nothing but the draft, Pi value is this value. So, if and W value is known. So, if you substitute this one from here, you can find out what is the value of W R1. So, now you will verify this condition, whatever value is coming, whether it is giving us this condition satisfied or not. If not, that means if not, we have to reject the case. That means the tractor is not suitable, the tire which is fitted is not suitable. We have to put some more weight at the front. So, rolling resistance will increase. Okay. So, that means this tire diameter is taking a role here. So, you have taken R plus 15. So, tire diameter is taking a role. So, this exercise after you finish what is the dynamic weight, the next thing is the pull which is developed by the tractor. So far you have not calculated. So, you have to now calculate how much will be the pull that should be greater than or equal to the draft value which is required to pull the implement. So, for finding out the pull which is developed, you can take the help of Brix's equation. So, that means you have to calculate the mobility number, then at different slip values starting from 5%, 10%, 15%, we have to find out what is the pull which is developed. We cannot exceed beyond 20%. Our maximum range should be maximum range of slip should be within 20%. So, at different values of slips 5%, 10%, 15% and 20%, we have to find out what is the pull which is developed using Brix's equation. Brix's equation gives you tractive effort, the torque ratio. So, torque ratio minus rolling motion resistance ratio. So, that will give you the coefficient of traction, and in coefficient of traction if you multiply the dynamic weight, so that will give you what is the pull which is developed. Okay. So, let me repeat again, for calculating pull there is no direct equation given by Brix-Yates. We have to find out the torque ratio first, then find out the rolling resistance ratio or the motion resistance ratio, and the difference of these two will give you the coefficient of traction. or coefficient of net traction. So, which is nothing but P upon dynamic weight of the dynamic weight coming on the wheel or axle. Now, you multiply whatever value you are getting, you just multiply with the dynamic weight. So, dynamic weight of the rear front axle we have calculated just now. Similar exercise you have to take carry out at this line, center line of the front wheel. That means you need to know the tire diameter which is provided at the front. Okay. So, we find out dynamic weight of the front axle, dynamic weight of the rear axle. Since it is a two-wheel drive tractor, so this has to be multiplied with the dynamic weight on the rear axle. So, that will give you what is the pull which could be developed by a tractor, and that should be greater than this draft requirement of the implement. So, that is the third condition which has to be satisfied. Okay. The first condition is the steering ability, second condition is the draft should match, third condition is the slip should be within 20%. If these conditions are satisfied, then only you can say, okay, this tire which is selected is good enough to carry out this tillage operations. So, the possibility is there could be many tires available in the market like 13.628, 16.928. So, it may happen that both the tires will satisfy this condition. All these three conditions are satisfied by both the tires for pulling a two-bottom moldboard plow. So, what you have to do is if you really want to know the pulling ability of the tractor, then you can increase the number of bottoms of moldboard plow. That is one possibility, and then carry out the same exercise and see whether these three conditions are satisfied or not. If not, one of them is not satisfied, that means that tire is not suitable. Suppose in the worst case that both the tires which I mentioned may satisfy the three conditions for increasing the number of bottoms of moldboard plow, then comes the cost factor, that is the fourth component. So, if both the tires are suitable, then we go for finding out which one is economical. Economical means where I have to pay less to purchase the tire. So, obviously, the smaller size will cost less. So, you have to select the smaller size there. So, these are the procedure which has to be followed for selecting a tire. That means, initially you have to calculate for the maximum draft requiring implement, how much draft is required. Then we find out what is the draft what is the pull or draft which is developed by the tractor using Briggs's equation. Then we find out what is the dynamic weight which is coming. I think dynamic weight is required before calculating Briggs's number. So, in the second step, the dynamic weight calculation for the front as well as the rear wheels are to be done. In the third case, we have to find out the pull developed by the tractor under different slip conditions. Maximum we can go up to 20%, and once these are calculated, that means the pull which is developed is within 20% and it is satisfying the draft requirement of the implement. Then the second thing is what is the steering ability. That means the weight on the front axle should be more than the 20% of the total weight. So, these conditions are to be satisfied. If these conditions are satisfied for say x number of tires, so then question is which tire is giving you less cost. That means what is the purchase price of these tires. The tires having lesser purchase price you can select. So, I hope this will give you some idea. So, only difficulty here is the ASAB equation. Now, the ASAB equation says that draft values which are predicted is plus or minus 50%. So, since we do not have any good predictive equations, available to estimate the draft. So, that is why you are relying on the ASAB equation. Otherwise, the procedure is simple. So, what we can do is a program can be developed by which by giving the information like the tractor specifications, CG distance, wheelbase, then static weight distribution. If those informations are given, then implement informations are given and the soil conditions are given, then immediately it will calculate on all these parameters which I mentioned, like draft, pull, the draft developed by the tractor, then whether the condition is satisfied, whether this draft which is or the pull which is developed by the tractor is within 20% or not. Then next is what is the weight dynamic weight coming on the front axle. If that condition, that is, it should be more than 20% all the time, 20% of the total weight. If these conditions are satisfied, then immediately the program will say, okay, this is the output. Output means this tire is suitable. So, that becomes easier task. So, basically I attempted to calculate the influence or discuss the influence of length on tractive performance of a truck, and there we found that a shorter truck has to slip more to develop the same tractive effort as compared to longer truck. So, a longer truck will slip less. So, it is better to have a longer truck to develop more draft or more tractive force. And we also discuss what are the procedure to be followed for selecting a tire for a given tractor, taking into consideration the maximum draft requiring tillage implement. That is all. You can have these papers and these books where you can where it will be helpful for you by referring this. Thank you.